Welcome, everyone. This is the first addition to my Paraview tutorial. Um, we'll be discussing compression strength after impact of composites. So let's first open up the file. You'll need a VTK file. So there's several ways to develop these VTKs. You can look at the user manual on how to develop them, but we already have some. Most of them have, um, mine already have a VTK for every step. So basically, and usually Paraview will just bunch them up all together when it sees this. So once you see that, all you do is just press OK. Click apply, and it'll take a while. And Paraview is pretty quick, but the information that I'm uploading to Paraview is on my hard drive, so I apologize if it's a little bit slow. Okay, so you see cluster. Cluster is just a reference to the volume. So if you have 32 plies, it's going to give you 32 clusters. But of course, it's not. Oh, you don't always have plies involved. You could have different volumes, and so we have CDM. CDM is fiber breakage. We have delamination. We have major, minor, principal strains, mesh, independent cracking, steps, strains, stresses, von Mises. This is stress as well, von Mises stress. The same thing with E1 and E2. Displacements like UVW. So if you wanted to look at some of this, you can just do X. Now, originally, if you just do this, usually it looks like this. So, and it's 2D, but or you could do 3D and you can look at it three-dimensionally, right? So it does that. We're going to start off with looking at the damage. So the initial damage, so let's look at the initial damage. So that's, I'm going to put this as delamination so we understand what's going on. We do delamination so we know. It automatically gives you a value range. So in this particular case, you want to start from 0.5 and then go to 1. You could be more strict. You could go 0.6, 0.7. That's a user option. So however you want it to look is up to you. I usually just do 0.5. And you get this green mass. But if you don't want it to look like this, now this is a volumetric information about the damage. So this is the actual internal damage that occurs in the composite. So you can see this is the impacted side, this is the back side. And so that's what you do. Now if you want to show differently, you could do surface. It shows displacement here, but you don't want that. You could do cluster. And so cluster gives you kind of a better understanding on what interface it's on. So you can kind of see like that 32, well, that's closer to the back surface. That 1 is closer to the impacted surface. That's where impact damage occurred. So this is kind of how it looks. And it's just a rough estimation. It's not perfect, but that's what you do. And that's it. So you could just do that, and you're done. So the next one, the next form of damage, I'm going to do cracks. So you could add a crack by just putting that. So this is a threshold. So in this case, I'm going to do MIC. So MIC, mesh independent cracking. You want to use MIC. Now when you apply thresholds, it gives you a minimum and maximum. It doesn't always refresh when you click on the scalars, so you have to sometimes do this. In this particular case, it's 0, 0 because it's in relation to this time step that you used. Sometimes it can be hard to kind of change that, but I think you can still do it. So 0.5, I just use 0.5. And I apply. And of course you don't see anything, but if you were to go to maybe step 50 where there's a little bit more action occurring, it'll take a while to load, you'll see some stuff happen. And so you see this gray stuff, that's a crack. Um, but we're still not done. I want to apply basically another contour similar to what we did with delamination for that particular. So you have to, in order to apply a contour to the mic, you have to select the mic. So that's what I did. So contour, in this case, I'm going to use the step to help me with that. And so you just select the step. There are better ways to model the crack, but this is a quick way to doing that. You just need one, so you see the values are between 10 and 20, so I usually pick a middle number. I usually say 15. And then I apply. So you kind of see that there's cracks if you, and this is volumetric, so you see what sort of ply they're on, and you see where they're occurring. The reason why they're kind of funky is because of the discretization of the model. This is a 0 degree of transverse matrix crack. So the curvature of this is not a reflection of the actual fiber. It's just a discretization of the model. Okay, but if you don't like that color, usually now one reason why I don't like that is because when you do this view, right, which is just out of plane, you kind of don't see them at all. But if you kind of give a curvature, you kind of do see them. So you could fix that. You could use basically surface with edges. So when you see the aerial view, you can kind of see them a little bit better. So that helps. Or you could do the wireframe, and the wireframe is kind of good. You could kind of select the line width too. You can do that, and so it's easier to see. Another bad thing about this though is that you can't really see the cracks in relation to the delamination. So you can kind of go back to the delamination. It has this opacity number, so you could actually put 0.2. And now you see where the delamination is in relation to the damage, the delamination. So that's kind of good. So you're seeing damage. In some ways, you can kind of see the wireframe, how Paraview views it. So that's another good thing. So you can kind of see what's going on. The next thing we're going to do is CDM damage. So you had to click on the model again. So you have to click on this top model. This is just a specimen, no pre-inserted cracks. CDM, and that's a preliminary delamination. I mean a preliminary deformation. So that's just kind of how I labeled it. In other models, you could actually pre-insert matrix cracks, and I actually pre-inserted morphology and delamination in this model. So that's kind of how I did it. But to do CDM, you do another threshold. So you click on the main model, you click on threshold, and this one, in order to calculate fiber breakage, it's using CDM. That's just what we use. You go to cluster CDM, and again 0, 1. You can do 0.5. Apply. And you can kind of see that this opened up. So you could change that again. You could do surface with edges to kind of show some stuff. And now you have kind of like a good representation of the damage, right? So you kind of have this transverse matrix crack, you have this delamination, and now you have fiber damage. And if you were to actually rotate some of this, the fiber damage occurs on the 0 degree ply. So you can see something like how fiber damage occurs in relation to transverse matrix cracks. And of course, there's also a morphology to this. So because it was impacted, there is morphology to this. It's kind of hard to see when you have so much damage, but that's kind of how it looks. So this is how it looks, right? But if you want to incorporate the actual composite, you could go back to the original model. You click on this eye, and it gives you this. So it kind of just covered up everything you just did, which is not good. So that's an easy fix. You could do solid color. You could also do other things like cluster strains to kind of see what strains, but as you begin to play with all these colors, it could get confusing. So sometimes it's easier to just do solid color. So I just do solid color. And also I just do wireframe. You could do surface with edges, but wireframe is easy. But even with wireframe, it's still kind of hard to decipher where these cracks are because it's really close to the mesh. So sometimes it's easy just to go from 3D to 2D. So that helps a little bit. And then you could play around with the colors. So you could go to delamination. Well, no, we're not going to do anything here. So you go to step, right? You want to change the colors. In this case, I want to change it to a red. We're looking at the back surface, so it's not going to get confused with the impact surface. If you're looking at, from the impacted surface, I would choose a different color. For fiber breakage, it's surface with edges. So you could do, instead of doing cluster, you could do solid color again. And instead of what color it is now, you could choose black. And voila, you have this image. And if you want to make this look a little bit 3, you kind of see better delamination pattern, right? So where it is in relation to the thickness of the body. All right. And so that's kind of how you can kind of view the damage that's occurring within the composite using these kind of parameters. So yeah, it's not hard. If you want to incorporate other things into it, you could also open, say, a fixture. And this is kind of like the fixture that was used in this experiment. You could put a filter, right? You could transform it since it didn't really do what it was supposed to, and you could rotate it 90 degrees, and it does it for you, and apply. You could apply translucence, or make 2.5. Kind of gives you an idea of how it looks still, but with just 2. And that's kind of how it looks. So basically, this fixture is just kind of a visualization tool, so you could see how boundary conditions were implemented in this model. So basically, these surface nodes of the composite were constrained in the z direction. A load was applied on the edges in compression, and now you can see how the damage grows given these boundary conditions. So Paraview has the capability of doing this. This is what it looks like. This is an older model, so okay. And I think that's pretty much it. You could go to File now and basically save animation. Usually I just do 1 here, so I could change that to 1. No, not yet. Cancel. Sorry. You can change that to 1. This is kind of like Python, if you're familiar with it. So if your steps are from 1 to 100, this is going to be 0 to 99. So if you're looking to start from step 25, you're going to have to put 24 here. And if you only want to cover, you don't care about that last step, you care about step, in this case, my step size went to 90, but you're interested in 88. That means you have to put an 87 here. So yeah. And then you save animation. You could do YouTube 2. I'm not gonna press OK because I think that's easy. But then you could come up with a video that looks like this and so forth. And you play it. You can see damage grow, and then you see it grow also. And so that's kind of how it stops. Also, you notice that it was kind of rotated. You could actually do that. You could go back to 2D. You go to this camera, adjust camera. You put a 1 here. Well, actually, it's -1. And I don't know why it does that, but it does that. Cancel, sorry. So basically, you want it to look like this. Close. And so automatically, this looks like what was occurring during the test. The top of the composite was constrained by the crosshead of the load frame, and then the bottom of this composite was loaded with the actuator going upward, and that's how the experiment was. So you could do this if you want to go back and actually look at some of the strains and relate that to DIC. You can still do that kind of stuff. And especially if you're just interested in this window, it kind of helps with that as well. If you wanted to actually if you wanted to cut those areas, you could cut them with using these tools, and it will help you slice it or clip it however you want to look at it. It will allow you to do that. You could do a box. It's actually pretty cool. But yeah. But that concludes. Oh, something happened, but that concludes my tutorial. I hope you enjoyed it. Have a good day.